Hey guys, this is video of Bosch fuel injection. So we're on to section 2.4 fuel pressure. So it says here, both carburetors and fuel injection systems rely on pressure or pressure differential to dispense fuel into the air intake airstream. The atomized fuel vaporizes and mixes with the air to produce a combustible mixture. In a carburetor system, the fuel system supplies fuel to the carburetor float bowl. The bowl is vented and the fuel in the bowl is at atmospheric pressure. Intake air passing through the carburetor's venturi creates low pressure in the venturi, lower than atmospheric pressure. The pressure differential between atmospheric pressure in the carburetor bowl and the reduced pressure in the venturi chamber causes fuel to flow from the bowl through the discharge nozzle and into the intake airstream. So we got a diagram. So we got the throttle value, air pressure at venturi 5 to 10 psi. Oh yeah, atmospheric pressure 14.5 psi. Fuel metering jet, discharge nozzle, venturi choke. Oh, so that's letting more air in, right? It's figure 2.1. The fuel metering part of a carburetor operates with small differences in pressure. Fuel in the bowl at atmospheric pressure versus reduced pressure at the discharge nozzle in the venturi. So, he's talking about this being the bowl. Choke. Oh yeah, right. And the intake airstream. I just repeat that actually. In a carburetor system, the fuel system supplies fuel to the carburetor float bowl, which is that thing. The bowl is vented and the fuel in the bowl is at atmospheric pressure. Intake air passing through the carburetor's venturi creates low pressure in the venturi, lower than atmospheric pressure. The pressure differential between atmospheric pressure in the carburetor bowl and the reduced pressure in the venturi chamber causes fuel to flow from the bowl through the discharge nozzle and into the intake airstream. The pressure differential in the fuel metering system of a carburetor is usually pretty small, only a few pounds per square inch. In contrast, fuel injection systems introduce the fuel at higher pressures, anywhere from 30 to 90 psi, depending on the system and the specific operating condition. Fuel delivery at these high pressures ensures that the fuel is being atomized and it is vaporized more completely in the airstream. Higher fuel pressure also makes possible more precise control of fuel delivery. Oh my goodness. 2.5 pressure measurement. As I get into the specific functional details of each of the various fuel injection systems, you'll see that many functions and relationships are defined in terms of pressure. They may be fuel pressure values in the fuel system, manifold pressure in the airtake system, or atmospheric pressure. I may be talking about differential pressure, the differential between two opposing pressure values somewhere in the system. Oh boy. Ew. So, in any case, pressure values are always expressed in one or more of the following units or terms. All are correct. With the appropriate conversion factors, all are interchangeable, obviously. Fortunately, the mathematics required to convert between the differential units is simple. Pounds per square inch psi, the English system unit of pressure defined as force pounds divided by area square inches. Atmospheric pressure at sea level is approximately 14.5 psi. Bar, a metric term derived from barometer or barometric pressure, atmospheric pressure. 1 bar is approximately equal to standard atmospheric pressure at sea level, so 1 bar equals 14.5 psi. Alright. Typical fuel pressure in a post-injection system might be 2.5 bar or about 36 psi. European manufacturer specifications and pressure gauges usually refer to pressures in bar. Kilopascal kPa. The proper metric unit for pressure, 1 bar equals 100 kPa, so atmospheric pressure at sea level is 100 kPa, used mainly in the US. Oop, focus. Oh, kilopascal. I like the way you put the proper metric unit for pressure. Kilopascal. 1 bar equals 100 kilopascal, so atmospheric pressure at sea level is 100 kilopascal, used mainly in the US. Oh, inches of mercury, INHG. Oh, they also have millimeters HG, don't they? But originally refers to measurement of pressure using a mercury manometer. Hg is the chemical symbol for mercury. This is a term used to specify manifold vacuum. 29.92 inch Hg is the difference between standard atmospheric pressure at sea level and absolute vacuum. Table A lists the various units of pressure and appropriate conversion factors. Oh, right. So we got unit PSI, bar, kilopascal, inches, Hg, atmospheric pressure, 14.5, 129.92. Oh yeah, then all the conversion factors. I'll put this little table. I can put this little table in the description. And it's got, if you watch the local TV weather person, you'll see how barometric pressure readings inches Hg are used to describe atmospheric pressure changes. That's in America. Listen to the references to highs and lows. Changing atmospheric pressure changes the density of the air. Denser intake air can slightly alter the fuel injection ratio and may affect how your engine operates. Some Bosch fuel injection and engine management systems have features which allow the system to compensate for variations in air density. Right, okay then, that's a nice another little section done, but it's about coming up to 10 minutes, so I'll leave it there for this video, and then see, that was quite interesting, wasn't it? So now we know about 2.5 bars, 36 psi. So hopefully you enjoyed that video, and then see you in the next video. Thanks for watching. Please like and subscribe. Thanks.